So at that time, we are using one analysis. Okay, so we are using one analysis, and the name of that analysis is, so very important, loop or mesh analysis. So now we are going to see, so what is the meaning of this loop or mesh analysis, and the steps. What are the different steps we are following to apply this mesh or loop analysis? Okay, and how to apply this mesh or loop analysis to find the current in various branches. Okay, now so all of you understood why we are moving to loop or mesh analysis instead of current division rule. Everyone accepted? Current division rule, is it preferable everywhere? No, right? It's not possible, and it's not preferable to use the current division rule everywhere. That's the reason why. So instead of current division rule, we are using one more analysis, that is loop or mesh analysis. So now we'll see. So what are the different steps in the mesh analysis or loop analysis, and how to apply this mesh analysis for any network, and how to find the various branch currents by using this loop or mesh analysis. That means if you apply this loop or mesh analysis, I can find out any branch current. What is the current passing through this branch, or what is the current passing through this branch, or what is the current passing through this branch. That means I can find out any branch current, so by using this loop or mesh analysis. Okay, na? So I can find out the branch currents, any branch currents, by using this loop or mesh analysis. Right? Understood now why we are moving to the loop or mesh analysis instead of current division rule. Right? So once we got that point, so all of keep it as loop or mesh analysis. For what purpose we are using this mesh or loop analysis? Anyone? Yeah. So yeah, to find the currents in any branch. Okay, it's not just in a single branch. Okay, if you apply mesh or loop analysis, we will get the each and every branch current. Okay, so we'll see. Okay, how we are getting those each and every branch currents, right? So all of keep it as mesh or loop analysis. So now we'll see how to apply this mesh or loop analysis. I will tell you by simply considering a rough circuit or a network. So I'm having a network like this. So with some voltage, so V, and this resistance is R1, and this resistance is R2. So R3, R4, so like this I consider a network. So now what I'm doing means, so now we need to apply the mesh analysis network, and we need to find out what the currents in various branches, right? That means I need to find out what is the current passing the resistance R1, R2, R3, R4, and R5. So that means any branch, in any branch, we can find out the currents. So by using this mesh or loop analysis. Okay. So in the mesh or loop analysis, okay. So I will tell you the steps. So what are the different steps? So we need to follow to apply this mesh or loop analysis. The first step. Okay. So the first step in mesh or loop analysis is identify the number of loops or meshes. Now anyone in this network, how many loops we are having? Can you guess? How many loops we are having? It's not 3, it's 6 only. Good mark. Yeah, it is 6. So the number of loops here is 6. But how many meshes we are having? Good. So we are having only 3 meshes. That is the reason why here you can observe here. I kept the heading as mesh or loop analysis. It is not a loop analysis. If you consider loop analysis means we need to consider 6 loops here. Okay, now we need to consider 6 loops here, but here we consider the meshes, not loops. Okay, now in this network or circuit, we are having only 3 meshes, and I will indicate what are those meshes. Observe here, this is one mesh, right? So this is one mesh. Okay, now so this is another mesh, and this is the another mesh. Understood? So in case of mesh or loop analysis is identify the number of meshes. How many number of meshes we are having in this network? Which of the network we consider now? So in this network we are having 3 meshes. So this is one mesh, another mesh, and another mesh. Okay. Now, so after identifying the number of meshes, the next step in case of mesh or loop analysis is after identify the number of meshes. So we need to assume so it is a purely assumption. So we need to assume the each and every mesh current or loop currents. Okay, now, in every mesh, in every loop, so we need to assume the currents, and so that current direction, so it will be completely our assumption. In this case, I consider 3 meshes now. Yes, sir, we are having 3 meshes. Okay, now what I am doing means I am assuming it's assumption, purely assumption only. So I am assuming this mesh current or this loop current as I1. All of you understood. So what is the current direction I consider? Is it in clockwise direction or anti-clockwise direction? It is assumption. Yeah, good. It is a pure assumption. If you are showing interest in anti-clockwise direction, you can assume this I1 current in anti-clockwise direction. Right. So there is no that means compulsory that you need to assume the currents only in clockwise direction. Right. So for this loop or for this mesh, I consider this mesh current. We are calling that mesh current, not branch current. Try to understood. So there is a difference between branch current and mesh current. So here I1 is the mesh current. Okay. So right. Similarly, in this mesh, I consider so one more mesh current, that is I2. Again, it is also in I consider in clockwise or anti-clockwise. Clockwise only I consider. It is your choice. Here observe here. Here you can consider clockwise, and again here you can consider anti-clockwise, and in this mesh you can consider clockwise in different direction. That's not a problem. And when it comes to here now, here I consider the third mesh current, that is I3, and again it is also in I assume that in clockwise direction. All of you understood now? So the first step in case of mesh or loop analysis is so identify the number of meshes. So after identifying the number of meshes, the next step in case of mesh or loop analysis is to assume the loop currents or mesh currents. Okay, now we need to assume the loop currents or mesh currents. Total loop currents equals how much? Total number of the meshes. If we're having 3 meshes now, so you need to assume how many currents. So 3 currents you need to assume. All of you understood 2 steps in the mesh analysis, right? Yes or no? Yeah, good man. So after assuming this, so loop or mesh currents, the next step in this mesh or loop analysis is we need to indicate the polarities, or we need to indicate the polarities across each and every element. We need to indicate the polarities across each and every element based on our assumed loop currents. So once again I'm repeating, we need to indicate the polarities for the voltage drops. So we need to indicate the polarities for the voltage drops across each and every element. Okay, now based on what? Based on our assumed, yeah, our assumed loop current direction. Okay, now we already assumed the current, now that current direction we need to indicate the polarities for the voltage drops. Now anyone can you tell me the what is the polarity for this R1? What is the polarity at this point? Yeah, it should be positive now because the current is moving in this direction. It should be negative. First of all, yeah, good mark. First of all, of the real. Instead of clockwise direction, first of all, if you consider this I1 current in anti-clockwise direction, it is your assumption. At that time, what is the polarity here? Here will be positive. Here will be negative. Okay, purely it is your assumption only. It is based on your current direction, your assumed current direction. Similarly, so when it comes to R2, what is the polarity here? Because of the current I1, I am talking. because the current I1. What is the polarity here? Plus, minus. Understood, right, everyone? How I am indicating the polarity? Yeah. Now coming to this R3 resistor. For R3, what is the polarity here? Plus, because I2 current is passing in this direction now. Now, similarly, R4 with respect to I2, with respect to current I2. Okay, now what is the polarity here? Plus. What is the polarity here? Minus. And observe here, again, when it comes to R2, with respect to I2, with respect to I1 is plus minus now. With respect to I2, so here positive, right? Yes, sir, with respect to I2. So here positive, and on the top we are having negative. Understood? How I am indicating the polarity. Right. Similarly, for R5 also, what is the polarity here? Plus, yeah. What is the polarity here? Minus. And similarly, for R4 also, what is the polarity here? Plus, and what is the polarity here? Minus. So this is the third step in case of mesh or loop analysis. Okay, now so once again I'm repeating. So all the steps. The first step is what? What is the first step in mesh or loop analysis? Good. So identify the number of meshes or loops. Okay. Now. So after identifying the number of meshes or loops, the next step is what? We need to assume the loop mesh currents or loop currents. Okay, it's assumption only, purely assumption. You can consider clockwise or anti-clockwise, clockwise or anti-clockwise, anti-clockwise. That's your completely your choice. So the next step is after assuming the loop currents, the next step is you need to assign the polarities. Okay, across each and every element for the voltage drops. Okay, now. So based on which currents? Based on your assumed loop currents. Okay, now. So based on your assumed loop currents, you need to assign the polarity. So clear. So this is the third step. So the fourth step is observe. So once if you assign the polarities, okay, once if you assign the polarities, then you need to apply the KVL. So KVL means what? Yeah, Kirchhoff's voltage law. Yeah, so you need to apply the KVL in each and every mesh. Okay, now for each and every mesh or for each and every loop, so you need to apply the KVL. So then you will get the KVL equations. Yes or no? Now in this case, how many meshes we are having? 3 meshes now. Yes or no? We are having 3 meshes, right? Yeah. So in each mesh we need to apply KVL. So in this mesh you need to apply KVL. So in this mesh you need to apply KVL, and in this mesh also you need to apply KVL. So then how many equations you are getting? How many equations you are getting? 3. Yeah, good. 3 equations we are getting. Now can we apply KVL? One by one I will do it. Can you apply the mesh, that means KVL? Kirchhoff's voltage law for the first mesh. Can you tell me? I can answer that loop. Yeah. So loop one consider. I will start from here. Okay, I'm moving in clockwise direction. Okay, so I'm moving in clockwise direction. So I'm moving from negative to positive. Now negative to positive means it is a positive or negative. Go to positive. V, right? So V. So I'm moving from positive to negative now. I'm getting some noise now. So minus I1 R1. Now all of everything. So it is very clear. What is the current passing through R1? Only I1 is passing in a very, very important observation. Observe here. So here for R1, if you consider R1, the only current passing through R1 is what? I1 only. But what about R2? How many currents are passing through R2? Yes or no? Yeah, good ma. So everyone observe here. But when it comes to resistor R2, so the resistor R2 carrying two currents, two loop currents or mesh currents. So one I1 current is so flowing in downward direction or upward direction? Downward direction. So what? Yeah, good ma. What about I2 current? The I2 current is moving in upward direction or downward direction? Upward direction. Yeah, good. So the I1 current is flowing in downward direction and I2 current is flowing in upward direction. Now, what is the resultant current passing through the resistor R2? So one current is moving in downward direction and another current is moving in upward direction. What is the resultant current? Observe here. So whether it is I1 minus I2 or I2 minus I1. We don't know the value, right? Value of I2 now. First suppose I2 value is 20 amperes and I1 value is 10 amperes. Then what is the resultant current? Simply 20 minus 10 we can take. Yes or no? We can take 20 minus 10. Right. But here we don't know the values of I1 and I2, right? Yes or no? So we don't know the values of I1 and I2. So whether we need to consider I1 minus I2 or I2 minus I1, we don't know. Because of that reason, here what I'm doing means we are writing KVL for the first loop or second loop. So we are writing KVL for the first loop or second loop. For the first loop, right? Yeah, good. For the first loop, if you are writing KVL for the first loop, okay now. If you are writing KVL for the first loop, assume that your first loop current I1, okay now. Your first loop current it is more than the remaining loop currents. Again, it is also an assumption only. So once again I'm telling, if you are writing KVL for the first loop, okay now. So at that time we need to consider that your first loop current it is always more than the remaining loop currents. Okay now. So here the first loop current is what? I1, right? Yes or no? So I1 current, right? So this I1 current. So and again we are writing KVL for first loop or second loop? First loop. Yeah, good. First loop now. So if you are writing KVL for the first loop means yeah. So we need to assume the current I1 is more than I2. And similarly, the I1 current is also more than what? I3. It is very, very important. So it is also assumption only. So assume like this. Now here, okay, now when it comes to here, we need to write I1 minus I2 or I2 minus I1. So we need to write I1 minus I2. Yeah, I1 minus I2. So when it comes to I1 minus I2 now, when it comes to I1 now, so what is the polarity here? Plus. So we are moving from positive to negative now. Negative means here negative. I'm getting some noise now. Right. So here we need to write minus I1 minus what? So minus I2 into what is the resistance here? R2. Is there any other terminals? Is there any elements in the loop? Only thing here now. It is equals to what? 0. Yes or no? All of you understood how I wrote the first loop equation. Very, very, very important. Understood or not? Yeah. Yeah. So now simplify this one. Simplify. So minus I1 into R1 minus I1 into R2 plus minus into minus means plus now. Yes or no? Plus I2 into R2. Okay now. Now what I'm doing means so uh, multiply. So multiply with the negative. So if you multiply with the negative now, completely equation. Then you get minus V now plus I1 into I1 into what? R1 plus R2, right? R1 plus R2. So minus I2 into R2. Yeah, I2 into R2 that is equals to 0. So minus I2 into R2 equals to 0. Now take this so minus V to right side. Then you'll get the final equation as what? I1 into R1 plus R2. Okay, now minus I2 into R2 equals to what? Equals to V or not? Yeah, good, V. So this is the first equation 1. All of you understood how I wrote the KVL equation, right? So now, similarly, can you tell me the expression for the second loop? I want the final answer. All of you try it now. I want to note it down roughly. That's not a problem. Can you write the expression for the second loop? Start from R3. So minus 2 plus 2 minus means minus now. Minus. Yes, Rajshekar, I'm getting noise, man, on your side. Yeah. So when it comes to R3 now, so R3 The current here is I3 now, right? Now, what about R4? What is the current passing through R4 now? Is it I2 minus I3 or I3 minus I2? Good. So it should be I2 minus I3 only. Why? Because we are writing KVL for which loop? Second loop now. If we are writing KVL for second loop means the second loop current must be greater than the remaining current. This is the assumption again. This I2 more than I1. And I2 value is also more than what? I3. Understood? So that is minus R3, I3 minus here I2 is not I3, so I2, right? R3 I2 now, R3 I2. So here I2 minus I3. So into what is the resistance? R4. Okay, na? R4. Again, when it comes to R2 now, how to write R2? What is the current there? I2 minus I1, right? For R2 resistor. I2 minus I1 into R2 equals to 0. I'm not simplifying this equation. Consider this is as a second equation. Okay, na? In the second equation, we are getting what? I1, I2 and I3 now. And similarly, write the third equation. So what about third equation? So minus R5 in minus R5 into I3. Yes or no? All of observe. Now what about this V? We are moving in clockwise and a plus 2 minus means is it a minus or plus? Yeah, minus. Yeah, minus. Yeah, minus V. And now coming to R4 now. Again plus 2 minus means minus R4 into what is the current passing through R4? I3 minus I2 now. I3 minus I2. That is equals to what? 0. Okay, again here. So take this V to right side. So this is the equation number 3. So now in this case, total how many equations we got? 3 equations we got. Yes or no? Now, if we consider it is general, so general network now, it is a general network. First of all, consider, so this value says R1 equals to 2, okay now, R2 equals to 4, and R3 equals to 6, and R4 equals to 8, okay now, and R5 equals to, if you consider 10 volts, and consider this voltage as 10 volts, and consider this voltage as 20 volts. Okay, now, if you consider the values like this, now total how many equations we got? 3 equations we got. Yes or no? So we got 3 equations, and so in all these equations, which are the unknown values? No? I1, I2, and I3. No? Yes or no? So I1, I2, I3 are the unknown values, right? The remaining values we know now, right? That means finally we are getting 3 equations. We are getting 3 equations with how many unknowns? How many unknowns in this case? 3 unknowns we got. Yes or no? So we are having 3 equations with 3 unknowns. Can we solve the equations? Yes or no? So these are, yeah, these are like algebraic equations only. X plus CZ equals to D. Yes, they are like, so they are like this only. We are having 3 equations with 3 unknowns, I1, I2, I3. If we solve the 3 equations, then we will get the answers for I1, I2, and I3 values. So once if we are getting the values for I1, I2, and I3 values, can we find out any branch current? Yes or no? For suppose I1 value I got 10 amperes. Okay, now, and I2 value I got so 5 amperes. Just assume. Now, what is the current passing through this R2? 4 ohms. What is the current passing through this 4 ohm? R2. So 10 minus 5, right? Yeah. So simply 5 amperes only, right? Yes or no? That means once if we got the mesh or loop currents, then we can find the each and every branch current. All of you understood what we are doing. So once again, I'm repeating. So what are the different steps in case of mesh or loop analysis? The first step is what? What is the first step? Identify the number of loops or meshes. So what is the second step? What is second step? Yeah, yeah. Assume the loop or mesh currents. It's your choice. Okay. What is third step? Yeah, good. Assign the polarities for each and every element. Okay, based on our assumed loop currents or mesh currents. Right. So what is the fourth step after assigning the polarities? We need to apply the KVL, right? Not KCL, KVL. So we need to apply the KVL for each and every loop. Then we are getting what equations we are getting. If we are having three meshes now, we are getting how many equations? Three equations we are getting. Right. So on the fifth step is what? Solve the equations. The fifth step is solve the equation and find the each and every mesh or loop current. Okay. So once if you find out the each and every mesh or loop currents, can we find out each and every branch current, right? Yes or no? Can you find out each and every branch current or not? Yes or no? Yeah. So yeah, good. So right. So all of you understood now the procedure or the steps for the mesh or loop analysis. So later we will verify whether the mesh or loop analysis it is giving the correct answers or not. We will verify it with the help of current division rule. Okay. So as of now, so just to follow these 5 steps, all of you note down now. I will dictate all the 5 steps. Note down everyone. Yes, note down please. First note down. Mesh or loop analysis is used to mesh or loop analysis is used to find mesh or loop analysis is used to find the values of mesh or loop analysis is used to find the values of current in any branch. Yes or no? Are we finding the current in any branch or not by using this mesh analysis? Keep in mind this analysis is very important. I will give so many number of problems based on this one. You need to solve it. Keep in mind. Then keep it as steps for the mesh analysis. So what are the different steps for the mesh analysis? What is the first step now? Yeah, good. So yeah, good man. Identify the number of meshes. Yes or no? Or loops. So what is second step? After identifying the number of meshes, yeah, assume the mesh currents, mesh or loop currents. It is purely assumption only. Assume the mesh or loop currents for various loops. Okay, now? So what is the third step? Not yeah, good. It's a polarity. Assign the polarity. No doubt. Assign the polarities for the voltage drops across assign the polarities for the voltage drops across each element due to assumed loop currents. So now we are assigning the polarities based on our assumed loop currents only, right? Due to assumed loop currents. Right. After assigning the polarities, what next? What next, mark? Yeah, apply KVL. All of you know down. Apply KVL to the various loops. Apply KVL to the various loops. Apply KVL to the various loops and obtain the equations. And obtain the equations. After obtaining the equations, what we need to do? We need to solve now? Yeah. Solve the equations. No doubt. Solve the equations to find the values of various loop currents with the help of loop currents we can find what? Branch currents, right? Yes or no? Once if you find out the loop currents now, so with the help of loop currents we can find the branch currents. Understood? These are the different steps we are following for what? So we are following for mesh or step analysis. Yeah, good. Right. Understood now? Now all of you draw one general circuit. This is the general circuit. For this general circuit, we need to apply. Okay, now you need to apply the mesh or loop analysis and write the equations. Everyone, copy it, ma. Just I consider here only two circuits now. In that, so in the earlier analysis, I consider 3 circuits. I consider here I consider only 2 simple network. All of keep bring us apply mesh analysis. Note down that apply mesh analysis for the below network. It is a general network, ma. For this general network, you need to apply the mesh analysis and write the equations. Follow step by step. So consider this resistance value as R1. This is consider R3. This is R2. And this is R4. Right. So now if you want to apply the mesh analysis for this, yeah, we need to assume the loop currents now or mesh currents. Here I will assume for this loop first. I consider this loop current as I1. And I consider this loop current as I2. So indicate this loop current I consider as I1. This loop current as I2. Right? No doubt. Assume two loop currents, I1 and I2. Okay, for your understanding, I'm telling all these things. In the exam, you no need to write all these things. Directly you can apply. Assume two loop currents. So what they are? I1 and I2. So loop currents, what is the next one, mark? So we need to assign the polarities now. Yeah. Indicate the polarities based on what? Based on, yeah, based on the current direction. So for R1 here positive, right? So here negative. Similarly for R2 positive. Please indicate, ma, very simple, because I'm telling step by step, so it will take some time. Plus, so minus, here plus and minus, and again for here plus, yes or no, and again minus. Okay, now so write that point also. Assign the polarities. Polarities for R1, R2, R3 and R4 based on assumed loop currents, right? So based on the assumed loop currents, we need to assign the polarities. After assigning the polarities, what the next step, ma? Yeah, apply KVL. The fourth one is here I will write apply KVL for loop. Now anyone, what is the KVL equation for the first loop? We'll start from V, right? So V minus, yeah, V plus minus, not plus, V minus, yeah, into R1 minus which currents we need to consider? I1 minus I2, no? Right? Good. I1 minus I2 into R1. R2, good. No? That is equals to 0. Right? Simplify this equation. If you simplify this equation, what we'll get? Plus I1 R1 now, plus I1 into R1 plus R2 now, I1 into R1 plus R2 minus I2 into R2. Take that minus V to right side directly, I'm taking. Okay, now equals to V. Understood, everyone? Yes or no? Just I simplified that side. Similarly, write the first, so second KVL equation also. Similarly, apply KVL to, I will take 2 more minutes for loop 2. So what is the KVL equation for loop 2? Start from R3 directly. Minus, what is the current? I2, right? I2 into R3. Okay. Minus I3 into R4. Right? Again, minus what? I3 minus, yeah. It is I2 one. Good, I2 only. So minus I2 into I2 minus I1 into what? Yeah, into what? Equals to 0. Again, simplify this equation. If you simplify this equation, what is the relation? So what is the equation we are getting? First, here I consider I1. Already plus, so minus into minus plus now. That is I1 into R2 now. Right. Minus I2 into what? R2 plus R3 plus R4 equals to 0. Understood, everyone? Now we are having equations, ma. We are having 2 equations. with how many unknowns? Two unknowns, keep in mind. So here the unknowns are I1 and I2 only. That is the fifth step. Okay. What is the fifth step, ma? Solve. Yeah, solve two equations and find the values of what? Find the values of I1. Good. I1 and I2. That's it. So once if you got I1 and I2 now, can you find out any branch current, right? Yeah. For suppose consider I want to find out the current passing through R2 now. Simply I can consider I1 minus I2 or I2 minus I1. Understood everyone how to apply mesh or loop analysis.